Hello everyone, I'm a reporter called Xinxin. I will reduce my presentation. The title of my paper is a review of additive manufacturing 3D printing in aerospace technology, materials, applications, and challenges. It has 9 parts. The first part is introduction. The second part is main process in aerospace, including first deposition modeling. The first deposition modeling is a sort of material extraction process to manufacture small plastic components through heated extraction and thereby layer deposition of materials. This technique is commonly used to fabricate polymer matrix materials. It fabricates polymeric components from polymer plastic by extracting from the nozzle, then melting and depositing it by adjusting the deposited processing parameters for the sake of the roughly developers FDI process. Each link should be gradually improved to achieve the goal of perfection. The second is selective laser marking. It is needed to one of the most prospective additive manufacturing technologies. It is a process of powder bed fusion. It is to slice the designed 3-dimensional model primarily, and then makes use of a high-energy laser beam in a protective atmosphere to absolutely melt pressurized powder particles of selective regions. After solidifies, repeats the operation of spreading and melting powder until the desired component is printed completely. The third part is materials, including metals and alloys, polymers and composites, and ceramics. The first part is aerospace applications, including unmanned aerial vehicle, satellites and rockets, aero engine, aerospace flight, and machine learning. In the aviation industry, unmanned aerial vehicles are increasingly utilized by numerous countries and industries. Their potential is constantly explored by scientists and entrepreneurs. For small, lightweight UAVs are an extremely promising application field. Aerospace applications may turn out to be the most considerable application of additive manufacturing technologies. Specifically, studies and carokies are confronted with radical temperatures ranging from liquid refrigerant to rocket engine combustion and evacuation. In same way, the carokies also have to endure high structure, vibration and acoustic loads, high pressure and high speed excesses in the combustion chamber, turboprop, subassembled and jet-propelled turbine. These technical changes have hindered the exploration of the unknown universe. Consequently, a great many researchers are constantly exploring the breakthrough of rocket engines. Research results show that nickel-based superior alloys, especially in chromium, have excellent crack properties, oxidation resistance and heat corrosion resistance, so they can be widely used in turbine blades, combustion chambers, and other domains. For example, SpaceX adopts high-performance alloy in chromium to manufacture rocket engine parts. With regard to our engine, the ascending of working temperature will first then impact fuel efficiency. Additive manufacturing has the capacity to machine high-temperature materials such as nickel alloys and intermetallic materials which are others to cast and process. These materials can also be employed at higher temperatures. The process can literally manufacture intricate sub-assemblies with diverse shapes, ingredients, structures, and performance on the basis of the demands of designers subsending the orthodox craft of processing parts. Additive manufacturing, also known as 3D printing or digital manufacturing, has opened up a new era for digital design and fabrication. In recent years, the additive manufacturing industry has been extensively concerned. Currently, cardinal countries in the world are incrementally promoting 3D printing technology as the basis of future manufacturing industry. Additive manufacturing is increasingly employed for mass customization and efficient production in healthcare, automotive industry, electronic industry, and the aerospace industry. Significantly, miraculous additive manufacturing has excited the aerospace industry. With regard to aerospace applications, additive manufacturing provides unparalleled flexibility in the geometry, material composition, and the lead time of components. By means of the manufacturing of highly complex, lightweight, and low-cost components. China is moving towards a revolution in aerospace manufacture. In terms of the current technical situation, especially launch rockets, it is difficult to fabricate accessories and repairs, structures, and the materials of simulated aero engines with complex geometry, which is another fundamental factor that forces aerospace departments to adopt 3D printing technology. From the perspective of a sustainable development, additive manufacturing not only has a firm foothold in the domain of aerospace, but also becomes the preferred manufacturing tool. In this paper, the dominating additive manufacturing technologies, the development of aerospace materials, and their outstanding contributions to the development of aerospace industry. In recent years, of the measures. In addition, the superiorities, changes, and prospects of additive manufacturing in the aerospace industry are also introduced. In this review, additive manufacturing technology in the domain of aerospace is summarized from the acquisition of raw materials, processing and manufacturing to the diverse applications of aerospace, upgradation of additive manufacturing